What's up, YouTube? Bear with me, this is my first video and it's probably going to be pretty low quality, but I wanted to share with you my electric penny board build after watching a couple recent posts on YouTube where the builds that I've seen starting to pop up are simply, in my opinion, a waste of time and money and a lot of energy and effort, and you just aren't going to end up with something worthwhile. So I wanted to share with you the board that I built and the little details that I found necessary to getting a rideable, worthwhile electric penny board. So currently it's in completely disassembled because I've graduated to a slightly larger board, larger trucks and larger wheels. All around the board is what I believe the smallest possible electric skateboard that's still a worthwhile riding experience. So I'll switch over the camera here and share the penny board with you. So like I said, it's currently in pieces, and it's actually a Kryptonics Torpedo, which is kind of the Walmart penny board with I replaced the wheels, bearings, and bushings to get a similar riding experience to a penny board. So the biggest drawback with the penny board is the width of the trucks is simply not large enough to accommodate for a motor mount. So I use a 8mm thick piece of aluminum to mount the motor to, and the problem with the penny trucks is trying to fit that motor mount in between this pulley and the part of the hanger where your bushings sit. There just isn't enough space to get a motor mount in there and have the motor mount sticking towards the center of the board. So I had to have the motor mount sticking out the back, which then makes the use of the kicktail, renders the kicktail useless. You end up just scraping your motor mount or your motor on the ground. So that's why we attached this protective plate to stop, if somebody leans back from just dragging the motor across the cement, or rocks from damaging the motor. So it is possible. I was getting about 6 miles range and about 18 miles an hour, which is downright scary on a penny board with such a short wheelbase. I'll show you next. I'll show you what I believe is the smallest electric skateboard that's worthwhile, to build. But I'll also share with you real quick the components that I used for this board. So you've got a Walmart Kryptonics Torpedo board that was $30. I actually bought this pulley from an international student from China that had it machined. It's a 54 tooth 3mm HTD pulley, and it's some kind of bushing set. I have honestly no idea what it was originally intended for. If you go to sdpi-si.com, they have all the pulleys and belts that you would need. And I gave myself an adjustable center distance of 69 to 76 millimeters, I believe, so that I could accommodate for, sorry about that, the video cut out, but I was saying I gave myself an adjustable center distance to accommodate for different pinion pulleys, attached to the motor, so I could play with the gear ratio and figure out what my motor preferred. So I ended up with a 26 tooth motor pulley and a 54 tooth wheel pulley, so 1 to 2 or 2 to 1 gear ratio, either. I'm not sure which way is correct, but the wheel pulley is double the teeth of the motor pulley, and that worked pretty well. It had enough torque to make it up pretty reasonable grade hills, and still had a top speed of around 18 miles an hour, which is way too fast for such a short wheelbase. So I used a KD 53-20 195 kV motor from Hobby King. I actually highly recommend that motor, but it's now on this board. So you've got your 190 kV motor, which is actually probably more like 220 to 240 kV based on the efficiency I was calculating. But it's a pretty solid motor. I'll probably have to replace the bearings eventually, but for a first build it works well. And then in this box I have two Zippy Compact they're 26 or 2700 milliamp hour, or 2.7 amp hour batteries, wired. I cut the wires and soldered them in parallel, which I don't recommend. The cells are now out of balance, and I'm not able to charge them properly, so they could potentially catch on fire, at any moment, I guess. I don't really know. But anyway, I also bought this cheap Turnigy B6 LiPo balance charger, and that's also in the box, which originally was flipped 180 degrees, and then I had this cover on it so you could see the screen for the charger and control it with these buttons. But for simplicity and less hardware, I have now used the 4 screws that used to hold this lid on, now hold the box to the deck, and I plan to move the screen over to the side, over here, or the other side, and have the screen off of the bottom of the box, just for protection purposes and a cleaner look. So it used to be the charging port would stick out here. You'd plug your laptop charger cord into there, and it's out of place right now. But yeah, I believe that's all the components. I used an Arduino to make a transmitter and receiver. It was for a school project. So this is my transmitter. There's a Adafruit trinket in there, and just I use a sliding potentiometer for the throttle. I have no brakes, and then a Arduino Nano, some generic brand, which I don't recommend using. I definitely recommend buying the name brand Arduino products if you do go this route, and you're just going to get a lot more consistency, and it'll just be a lot less sketchy if you decide to make your own radio, which I do not recommend. And then for the ESC, it's also in this box. I'm using a Castle Creations Talon 90, which seems to be working pretty well. I originally had a Red Brick 190 amp, or it's the same as the Hobby King. There's a couple different Chinese names for the same ESC. It's supposed to be rated for around 200 amps or something similar, and it worked. I don't not recommend it, but at the same time, I think that this Castle Creations Talon 90 is a better investment. The warranty on Castle Creations is pretty top notch. I believe if you break it and it's your fault, you get a replacement for half price, and if it's a result of a manufacturing defect, they'll replace it for free. So those are the components I recommend. The charger, you could probably find something nicer. It is a pain to wire everything to have it all in this box, but once it's all done, it should look pretty good. And I use this little key here, little EC5 connector. Don't buy the EC5 connectors from Amazon. They are a major pain to get the metal connectors to sit properly in these plastic adapters. So this would be for charging, and then this would be to use the board, and then you can hear it power on and see that. So just for a size comparison, the penny board I believe is 22 inches, and my deck is about 24 inches. This is just a skateboard. I went to a skate shop and bought a used deck for $10. It was a great deal. Oh, there goes the controller. And then I used a $15 Dremel from Amazon to cut it out, and cut it to this shape using this template from boardpusher.com. So if you're looking for the cheapest route possible, I don't recommend using the penny board, even though they are cheap. I now have a $10 deck. These are Gullwing 150 millimeter trucks. You can find them on eBay pretty cheap, but they're slightly narrower than like the Paris 180 millimeter trucks. So that is 180 millimeters. The Gullwings are 150, slightly narrower, a little more agile when you're weaving in between students going to class. So those are the trucks. Then I'm using these Bronson speed bearings because I just wanted to try something other than reds. And I'm using the shock pads off of the Walmart penny board. Then these are just, I got these from a Chinese international student along with this pulley. But these are the same as the eBay flywheel, cheap generic longboard wheels. You could probably buy the trucks and the wheels together for, you know, like $50 or $70. I'm not exactly sure. But the big wheels do make a difference when you're trying to go over sidewalk cracks. And you know, you can get away with the 70mm wheels, but the 83 are definitely better for cruising around and going over bumps. So I do recommend those. And so then for my receiver, one second here. Sorry for the delay. We're just gonna do this video in one take. So got a Arduino Nano. This is a Fearduino, which actually is higher quality than the Amazon or Fastech or Micro Center, you know, knockoff Arduinos. And then I'm just using a cheap 433 megahertz super heterodyne transmitter and receiver. So where did that, there's that transmitter. So in this box, this is just a project box. All the parts for this were purchased from MCM Electronics in Dayton, Ohio, or near Dayton, Ohio. It's a pretty cool store, except for this switch that came from Micro Center. But this combo, the transmitter and the receiver, takes a lot of hours of work, and I'm happy to share the code I use. I actually had to get help from a friend who's much better at programming than I am. I'm pretty clueless, but we do have some pretty good code for controlling the acceleration and overall twitchiness of the transmitter and receiver. You know, a lot of the RC hobby transmitters, like this kind of Fastech thing, it's very twitchy and it's hard to maintain speed. So that's why I switched over to the sliding potentiometer. You just have a lot more resolution and cruise control. So you set your speed and you keep going, and then when you want to stop, you knock it down and then turn really hard because there's no brakes. So, or melt your shoe. One of the biggest problems I had with this board was the range of these cheap Arduino modules. You basically had to hold the transmitter at the right angle around your knees, and any farther it would have been out of range. So we made this, we made a cheap dipole antenna out of like a window blind and 2 pieces of wire, and you just gotta Google it if that's the route you want to go. But it now has, you know, maybe 5 feet of range, and it basically works for riding the board, but you aren't gonna, it's gonna be out of range pretty pretty quick after you hop off, but I am now running a 26 tooth motor pulley or pinion and a 76 tooth wheel pulley, which works out to about 16 miles an hour with this motor, and has more than enough torque to make it up any reasonable hill. Anything you can ride your bike up in a low gear, this'll climb no problem. The only issue I have right now is those cheap batteries being out of balance. It is a risk. I don't know when they may decide to vent or blow up on me. I don't know if they ever will, but I do plan to upgrade to a lithium iron phosphate battery here in the near future, as soon as I have the funds for that. But anyway, yeah, I just wanted to share this electric skateboard build with you. Try to share some of the little technical details. I will have it posted on endlessphere.com in the near future. I do want to finish a couple things, but anyway, that's my board, and I'm pretty happy with it so far. Okay, so that's my electric skateboard. Again, if you want to go the pennyboard route, it is possible. However, it's pretty hard to keep all the electronics underneath it, and then you have the issue of the deck flexing, and protecting your batteries with a flexing deck is something I haven't really figured out yet. So I do recommend going with the skateboard deck. I moved the front trucks up about an inch to give you a little more space, because my box, that aluminum box would interfere if you tried to basically do a U-turn in the street. If you turned really hard, the wheels would bite on that aluminum box. So moved them up about an inch, and now that's not an issue. So either move your trucks up or make a smaller box. But anyway, I hope that helps. I do hope to in the future make a new hanger, one of these for the pennyboard with the motor mount as part of it. Just have a machined piece of aluminum, or cast, but realistically machined, and you basically flip the motor mount around so it's going towards the center of the board. I do have it drawn up in CAD, and it increases the wheel spacing by about 6 millimeters, which 3 millimeters on both sides shouldn't be noticeable, but that's what it takes to get the motor mount facing the center of the penny board. So anyway, that's my build. Again, be looking for it on Endless Sphere here in the near future, in the Stand-Up Scooters and Skateboards forum. But in the meantime, I'll try to answer any questions people have, but I can't promise I'll be very responsive. It's kind of something you gotta spend a lot of time on and figure out for yourself. And but it's a fun project, but don't expect to have it done in a weekend or two. It took me a couple months as a mechanical engineering undergrad, and doing this as a class project, it took over half a semester to get just a working board. And you gotta spend a lot of time on researching the components, A lot of the time I spent on it was dealing with the code for the transmitter and receiver. I don't recommend it unless you're a pretty skilled Arduino programmer and know how to mess around with libraries and stuff, but I am willing to share the code we came up with, but again, I can't really answer a lot of questions with it. I had to get help, and it's beyond me. But anyway, I look forward to seeing some electric paint boards out there. So see you in the next video, maybe.